Alright, I want to tell you a little bit about nomenclature rules, and the point here is to be able to see the name of a chemical and come up with its formula, or vice versa, see a formula and to name that formula. So this is learning how to speak the language of chemistry as far as putting names to formulas and vice versa. First kind of compound we're going to talk about is a binary compound. Binary compounds, any compound with just two different elements on the periodic table. When you're naming a binary compound, you always name the most metallic element first. So what do we mean by most metallic? If you look at the periodic table, the most metallic elements are going to be all of those on the left-hand side of the periodic table. You can see these are the metals, and then the non-metals will be anything on the far right. The metalloids are somewhere in between. So remember, we're going to name the metals first and then the nonmetals. So for an ionic compound, you have to have a metal and a nonmetal. And then if the metal is not group 1 or 2, you need to use a Roman numeral to indicate the charge on the metal, which will always be positive. That's called a cation. So what do we mean by group 1 or 2? Group 1 or 2, we just mean first column, that's group 1, or second column. So if it's in these two columns, you don't need to name the charge specifically, because column 1 is always +1, column 2 is always +2. But if it's these other metals in the middle, there's a lot of variability, and so then you need to specify with a Roman numeral what the charge is. So let's try some examples. Here we see calcium and chlorine. So what's the metal, what's the nonmetal? Well, calcium's over here, that's the metal. Chlorine's over here, that's the nonmetal. So we're going to name calcium first and then chlorine. Calcium is in the second column, the second group, so it's always +2, so we don't need to specify that. That's just implied by its location on the periodic table. So then this will just be called calcium, no Roman numeral, chloride. Let's try another example. Here you recognize that this is copper with chlorine. Notice I've got 1 copper and 2 chlorines. Copper is not in the first or second column, it's here in the middle. So we're going to have to specify its charge. Now remember, it's with 2 chlorines in this case. Each chlorine's -1. So if each chlorine is -1, but overall there's no net charge, it must be that the copper is 2+. So then we'll have to specify that it's 2+ by putting a Roman numeral, copper 2 chloride. Alright, after ionic, there's a completely different system of naming for covalent. That's when you have a nonmetal with a nonmetal. In this case, you're going to just have 2 elements from the right-hand side of the periodic table. And you need to use Greek prefixes to indicate the number of atoms of each element. So, what are those prefixes? You might be familiar with these, maybe from geometry or just words that you know. Mono means 1, so if you have 1 of a certain atom, it'd be mono that. Di is 2, tri, like a tricycle, is 3, tetra 4, penta 5, hexa 6, and so on. This list could go on, but mostly we'll only be using these smaller numbers. So let's look at some examples here. As is arsenic. You have 2 of those. S is sulfur. You have 3 of those. These are both nonmetals. So this is covalent, nonmetal with nonmetal. 2 is di, and 3 is tri. So the name then is diarsenic trisulfide. Notice we still end with "ide" for the second element mentioned, because we have this general rule for binary elements that you have to end the second one with "ide," and we still just name the element for the first one. So it's diarsenic not sulfur, trisulfide. Another example, P is phosphorus, O is oxygen, 4 would be tetra, so tetraphosphorus. 6 is hex, and you don't say oxygenide, it's just oxide. And some of those are just contractions because otherwise it would sound strange. And those kind of exceptions you'll just learn as you go along. But this is tetraphosphorus hexoxide, not tetraphosphorus hexoxygenide. All right, and then one more binary kind of compound. These are compounds with hydrogen and a nonmetal, specifically hydrogen. A couple of different situations here. These molecules are covalent as a gas, so you'd use the covalent system of naming. But they're ionic in water, and so then you use a different system, and this is new. This is special to this situation, and I'll talk about it in a minute, but you'll have hydro, as in hydrogen, blank, ic, acid, and you'll fill in the blank with what the nonmetal is. Okay, but first of all, as a gas, HCl gas, covalent as a gas, so we would just use our prefixes. So we have one hydrogen, so that would be monohydrogen. Monochloride, just like we did with the other binary elements. All right, but monos I have in parentheses here because usually, actually, if it's a mono, you just leave it off. So HCl gas, most people wouldn't call monohydrogen monochloride, although that's technically correct. They would just call it hydrogen chloride. But now HCl aqueous, so once you dissolve it in water, it becomes an acid. And so then we use this system, hydro, and then in the blank we'd say chlor. So hydrochloric acid. And that's it for binary compounds. Ternary compounds are those where we have 3, not 2, but 3 elements. So ternary compounds come in a few different flavors. First of all, acids. This is probably the trickiest part of the nomenclature presentation. For ternary compounds, acids, you have hydrogen and a nonmetal and oxygen. Maybe oxygens, maybe more than one oxygen. Now this nonmetal and the oxygens, these form common polyatomic ions, and you've memorized those. So those are just in the table in your textbook. So hopefully you know those, and then we can start the naming. To name, you have to know your polyatomic ion name if it ends in 8. When you add it to hydrogen to form the acid, you'll change the 8 to a ic, and then the word acid. Okay, and if your polyatomic ion name's in ite, you change the ite to us, and then add the word acid. So for example, ClO4 minus, that's the perchlorate ion. And you know that just because you've memorized it. Alright, so ClO4 minus is perchlorate. Now 8 becomes ic, acid. So when you add hydrogens to make this neutral, since this is -1, we're going to have to add one H plus to make it neutral to make the acid. So it's HClO4, and the 8 becomes ic. So HClO4 is perchloric acid. And so on. ClO3, that's the chlorate ion. 8 becomes ic, so HClO3 is chloric acid. ClO2 minus, that's the chlorite ion. Ite becomes us. HClO2 is chlorus acid. ClO minus, that's the hypochlorite ion. Ite becomes us, so HClO is the hypochlorous acid. All right. Another ternary compound is a ternary salt. Ternary salt will contain a metal instead of hydrogen, and then the nonmetal and the oxygen. So again, that'll be your polyatomic ions. In order to name these, you name the metal, and then you just name the polyatomic ion. So this is actually quite straightforward. So for example, NaClO4, when you see this compound, of course you can look at your periodic table and you'll see that sodium is on the left, so that's the metal. ClO4 you see as a chunk, and that is the perchlorate ion. So name the metal, that'll just be sodium, then name the polyatomic ion, perchlorate. Sodium perchlorate. That's it. NaClO, sodium again, but that's the hypochlorite ion, so this is just sodium hypochlorite. Alright, but now remember, if we have a metal that's not in the first or second column, which iron is not, then we have to specify the charge. So here, what would be the charge on the iron? Well, you can figure it out because ClO, the hypochlorite ion, is -1, and you have 3 of them. Overall, there's no charge, so the total must be 3 minus here. For there to be no charge for the whole molecule, the iron must be 3 plus. So then this is iron 3 hypochlorite. Finally, we've got hydrated compounds. To name a hydrated compound, you just name the main compound, and then you look at how many waters are appended with the molecule. So a hydrated compounds, basically you got your ordinary molecules, but in a solid they'll be accompanied by a specific number of waters per molecule. So in this example, you would name the compound, and then you'd add a Greek prefix to tell you how many waters. In this case there's 2, so it would be dihydrate. So the name of this compound, we've got iron. So with 2 chlorines, we know each chlorine's -1, so it must be iron 2 chloride, and then with the 2 waters it becomes iron 2 chloride dihydrate. That's all the nomenclature rules. Stick around and let's do some practice.